Okay, so hi and welcome everyone to another talk. Linux permissions, love them or hate them. You should learn about them, and that's what this next talk will be about. Linux permissions and hardening by simonmicro.
Yeah, thank you. Yeah, thank you. This is my third talk, so I hopefully didn't mess up anything this time. Yeah, who am I? I'm a software engineer and hardware engineer at day and as well as at night, whatever you need. I'm part of the Chaos Club Osnabrück, so if you have further questions, feel free to chat with me after the talk and visit our camp, where I do a little bit of networking there. So today I really like to nerd about stuff, and we will take a look at Linux permissions and hardening. This basically means we are learning how the basic permission system works, and then we are advancing a little bit in the more advanced topics with kernel modules we can load to actually tighten everything down. No worries, we will not code them ourselves, but just use pre-written software. So this talk is overall aimed at beginners, because we will talk quite a lot about the basic permission system, the basic way how the bits are indexed. So feel free to be more prepared for the second half of the talk, where we're talking about SELinux and actually locking it down on a kernel level, because then we will go a little bit more into detail. So, yeah, let's get started. Why is changed.mod 0777 not the greatest idea a user can have? After which they downloaded a file from the internet and are unable to execute. So, what does this mean? They just read this command somewhere in Stack Overflow. What is going on? So, starting off with user IDs and GIDs, you maybe know this command, ls-l, and then there's some file name, and you get this magic prompt, not prompt, but output, where you can read something about the file you've just inputted. What does this actually mean? So we're accessing here something with a mask. And whenever we do this in this talk, we will be the user John Doe, just to have something generic. And in the right-hand side, you can see the command syntax. We can see the user who owns the file. We can see the group who owns the file indirectly. And of course, file name. So let's get started. We can see this minus rw something going on. What does this actually mean? So you can see the colored highlighted segments of this output, which are basically 3-letter indicators of what the underlying 3-bit mask is. They are starting off with the owner information, so those are the permissions applying to the owner, then go on to the group, and finally to all the other persons and identities on the server or Linux machine. If you want to actually interpret them, it is basically a little bit math you need to be doing, because, for example, if you can see something like RWX, it basically means 4 plus 2 plus 1, and this equals to 7. So if we're now talking about changed.mod 777, this basically means give everybody the permission to read it, to write it, and to execute a file. Of course, under their own user ID. So this isn't maybe something you really want to on your systems. So let's play this through. We have this file, we are getting the file, and of course we're getting a permission denied, because this file is owned by Tom, and we are not Tom. And if you're taking a look at the permissions, this file is only readable for the user Tom, as well as the group Tom. So yeah, of course we cannot access it. We can change this if we calculate the permission we want to have. In our case, the owner should still be able to read and write it. We don't care about the group, so I will just set them to 0 and set the read permission for everybody else, so me. So we want to set it to 604 and just enter it here with the changed.mod command, and hopefully the permissions are now updated. You may notice there's a small difference. We're executing changed.mod, and we're injecting a 0 in front of the number we've just calculated. This is because we want to enter it in octal mode, just in case you're programming, as well as this 0 has a special meaning. We will take a look at this later, but just for now, we've gained access to the file, and we're hopefully happy with what we've obtained. So, ownership. Of course, a file is not only accessible by using this permission mask, we can also give another user the ownership of files, so they can delete them as freely as they want. And for this, there are 2 other commands available: change own, change group. I don't know, syntax is printed there. And if you want to own a file, we basically just, once again, doing the Joe Doe move and want to take over the file as a nerd. And in our case, we are just executing the file once again by providing change own, username, : nothing. Yeah, there's a nice advanced enhancement in change-owned available I've seen a lot of people not using. You can directly or indirectly specify to also take over the group ownership of a file by just providing an empty colon and without anything else behind it. You can, of course, specify a specific group, and in that case, the file will be taken over to the owner as well as the group, but this is just a fast way to get the full ownership of a file, both in the sense of who's the owner as well as the primary group. If you don't add the colon, it will just change the owner. So the group is still the same, maybe not even your own. So, yeah, talking about groups, how do we grant group access? Of course, we can also just execute the change group command, as mentioned before, because we did the change mod before with the double colon without anything behind it. We were already taking it over to the user's primary group, so nerd in this case, so this doesn't really change anything. Well, okay. So, we've now talked about the basic permissions. Questions, please, at the end. We've now talked at the basic permissions. Let's take a look at umask. Umask is something you may not know. It is a command available on your shell. And with this, you can set a mask which is able to restrict the default permissions whenever a file is being created. So many programs, or most programs I've seen so far, are just creating files with the 0666 permission. This has nothing to do with anything religious. It is just a normal permission to say everything is read and writable by everyone. But of course, you don't want to do this because maybe there's a file you just want to keep on your own. So in those cases, you should probably remove the bits to write from other people. And this is also the default umask you have in your system. It is by default configured to 0022, which basically means if we do the math actually here in words, umask bits and then AND them or logical AND them with the 0666, we get the resulting umask, and in our case, the default umask for everything we're doing on our Linux system will be 0644. So, which basically means the owner can read and write it, and everybody else can just read it. Yeah, in our case, here's a small example. We are just creating a file. We are just touching the file without changing umask before, and yeah, as expected, this is the resulting permission set. If you want to change the umask, we just enter this command before we do anything else. It will update this value in the background, and when we now touch the file, we are just keeping the file entirely to our own. If we are, for example, using umask 0077, which basically removes all the permissions from other users. So yeah, now we've got our private files. There's something interesting. Due to historical reasons, your home folder is open by default. Your home folder is by default created with the umask 0644, which means everybody can read the files in your home folder. This is something you should probably change by, for example, adding into your bash file these two commands to further restrict the umask, as well as taking actual ownership over your home folder. Because if you're taking the ownership over a folder, all the files within it cannot be accessed if they are not allowed on the folder itself. Of course, this will be a little bit bad. If you later on want to share a file with somebody else, you have to also allow them to access all the higher ordered folders as well. So this is the historical reasons why home folders are open by default, because you may want to share files. And if you lock it down, you cannot do this anymore. But on your home server or home computer, this is likely not the case. So, yeah, talking a little bit more about Linux permission specialities, there's something special going on with the user root, because root does not really care about permissions. He can do anything he wants as long as the kernel doesn't have anything against it. And we also have the 0 in front of all the permissions we've talked about before, so let's talk a little bit more about this. So, permissions are ignored for root because he is UID 0, so you can also rename your root user. I don't know why you would want to do this, but then as long as he has UID 0, he can do everything he wants. This is really important for those commands because we can now take over the ownership by using the root account from other files, from other users, or even their entire home directories whenever we need to. This shouldn't be really the case, except if you messed up your permissions. So, yeah, what was the source number we talked beforehand? It was always 0. Yeah, there are some specialty features on the Linux, which is setuid, setgid, and, well, I didn't find a nice term for it, so block, move, or rm. So let's get a little bit more into detail. I've talked about files are being owned by a user before, and whenever you execute this file, of course, it is getting executed as you, because you're the one calling it. But if you use setuid, this file will get executed as the owning user of that file. This is really important, for example, for systems like sudo to work or doas, because those files are SUID binaries, which are not executed to run as your user account, John Doe, but instead as root. This makes them really interesting for attacks, because you have basically a binary which can execute arbitrary stuff running called from a user as root account. And the same procedure is also available with the GID bit. And yeah, the third one. This is a little bit more confusing, but you basically can, with this bit, tell that one cannot move or delete any files within a folder if he's not the owner. Because this permission we are talking about before, if you have write access to a file, you can do everything with it. But if you don't have write access, you're still allowed to move this file or remove the file. So if you just take over the ownership of a file and locked out everybody else, this does not mean they cannot just move the file to another location. Maybe on a USB drive, which drops the permission, or he can modify it on another computer and then move it back. This is still allowed. You can, for this, set the this one, so 177, and on folders only. In those cases, these operations will actually not denied, but not permitted. This is just a little detail on the console. Okay, Linux capabilities and Linux revocations. There's a small problem in the Linux world. Oh no, before we go into the revocations, the capabilities. I've mentioned before we have the sudo binary, which is able to be executed as the owner who owns the file, which is actually root. But we can do so much more with this binary now. Like we can open arbitrary ports in the system, we can change ownership of files, we can do everything because we're actually running as root. For this, Linux has the concept of capabilities. And those capabilities can be modified with setcap or getcap, and can at runtime from the binary only be dropped. So a binary cannot get additional capabilities once it has started, and you cannot give any binary more capabilities. So what are those capabilities allowing us are to limit the capabilities of a binary to specific subsections or subsystems within the Linux kernel without actually giving all or granting all the permissions to this binary. For example, if you have a binary which is able to communicate with your sockets, ping is, for example, one of them, they need to open those sockets. They need to write with those sockets. On BusyBox implementations, on embedded hardware, they will likely run as root because nobody cares about permissions in embedded systems. But if you're running on your normal desktop computer, it is likely a binary which got assigned this capability to do raw networking access and bypass all the security measures there. And it is still not running as root, so this attack surface is a little bit less. Okay, also, permissions, this is like this problem with Linux revocations. They do not really exist. Permissions are only checked once a file is being opened. So if you open a file and somebody else wants to remove this access to this file, they can change own it, they can change mod it, take over the ownership, lock you out, really secure. But you still have this file opened. You can still write into it. You can still modify the content. So if you really want to be sure, you need to copy that file and delete the original one. Hopefully the file isn't big, so it's fast, but still it's annoying. So the Linux kernel got a proposal. The Linux kernel archives, I sadly wasn't able to get the link for you, where somebody actually implemented a revoke call to remove any open file handles on a file after the permissions have changed. But yeah, it wasn't implemented because so many other conflicts arise. On FreeBSD, this is differently. On FreeBSD, they have a revoke call, although it only works for block and character devices. So, still not for all the files. Yeah, messy. Okay, so access control lists. Like now we're getting a little bit more into the complicated side of these things. Let's talk a little bit about this. So, oh, nice. The animation got stuck. We want to share a file with a specific user. We don't want to create a group for every time we want to do this. For example, you have many files with different subsections of accesses you want to share with other users, be it reading, be it writing. In theory, we always need to create other groups. For example, even if you want to share a specific subset of files with other groups, you in theory have to add a new group, assign the permissions to this group using the classic permission system we've seen before, which gets tedious really, really fast. Like, this is the classic approach I'm presenting here. It doesn't scale well, and especially if you have unicorn files which only need to exist temporarily, this is like a management overhead you don't want to have. So there's a solution which is called the access control list in Linux, where you can use the get file and set get file ACL and set file ACL commands to manipulate additional entries for that. Okay, so now you can see their action and entries. What does this actually mean? So with actions, I mean at the set file ACL, actually the command -m to modify or insert an ACL entry, -x to remove an entry, and of course B to just clean everything up you did and which didn't work before, just because you cannot access it anymore. With entries, I'm talking about a specific syntax where you write scope, double colon, identifier, double colon, the mode you want to assign to this. So the scope can, for example, be a small lowercase u or a lowercase g to assign a user or group. You can also just skip it in case you have a unique identifier after this. And of course the mode, for example, just write or read. This mode can be written both in numeric form if you don't want to actually translate it into RWX or whatever, or can just be minus to remove all access. The evaluation order on such a file access control list is first the owner, so all the permissions for the owner are being evaluated, then the named users you've added into your ACL, then of course the owning or naming grouped, and then all the other permissions you have in there. This is maybe relevant if you're running into issues where you think you can access a file, but for example a previously inserted group is preventing that access. So here we have such an example. We have once again file, set ACL, modify foo, got access to it using, or got an entry to add it to it with read permission to y2025, and we are doing the same after this with for, which is the same version as read, just in decimal, and after this we are doing get FACL, and we can see we can access the files now. Yay! So now you can save all the different groups you need to create. You can just delegate access to a file really quickly using these ACLs. If you're using the ls-l command, I think there's even a plus besides the permissions, so you can see there's something else going on besides the classic permissions. Okay, so SELinux and AppArmor. This is like a really complicated topic, and it turns out I cannot really fit it into a 25-minute presentation, so this will be just a broad overview. Once again, the animations are really working today. The overall problem is with these permissions the users can change them themselves. They see something isn't working, they cannot execute an arbitrary file they downloaded from the internet, so they just go to their favorite search engine and enter anything there, change mod 777 it, and oh yeah, now it is working, but also anybody else can access it. They just disable the permission system. This is also important, for example, your home folder. As I've mentioned before, you can lock it down by using these two commands and restrict all access. But, well, many users don't do this. And we want to address it globally for anybody who's using Linux or distributions to really lock it down. Of course, also applications have access now to user files. Like, why is your music server having access to your password database? This shouldn't be the case, because he shouldn't access the home folder in the first place. Yeah, as I've mentioned, root is always able to bypass all permissions. This is also not good if you want to have a hardened system which prevents all this. For this, we have the Linux security modules, and for this we can restrict the binary, syscalls, operations on the file system, networking, and so much more by utilizing one of these SELinux or AppArmor utilities. This is working, for example, in AppArmor's case, in addition to the classical deny. So if you don't grant the permission to a user using a classical permission system, they will also not have the permission after you apply to AppArmor. AppArmor just restricts much more. Of course, those tools are also applying to root. So we are now, for example, if you're taking a look at Android, you cannot just take any binary which is executed as root and try to gain access to the full system, because this user is also bound by the same limitations or restrictions. We have some extensions there. If you, for example, using a hardened kernel and so on, you cannot just simply disable SELinux or AppArmor anymore, so it is really on for the whole boot. You cannot unload rules, and there's a lot of security discussion going on what you can do, but basically it makes your system more secure. And really important for those things like SELinux and AppArmor, they're not like a whitelist you apply. sorry. It is like a allow list you apply to your binaries and files. It is not like the deny list we had before, where we had to remove the permission for something. But now we can just do it globally and say everybody not in this list or any access not in this list explicitly permitted for something is going to be revoked. So yeah, SELinux runs on Android. Yay! This is also one of the primary locations you can find it, but not on your Debian server. SELinux is really, really, really complex. It is split up into different rule sets, types, and domains. Those are controlled using a file context. Every file has a context, and then you have interfaces as more or less standardized way how things should interact with each other. And yes, this is really, really complex. If you want to read on it, of course, I will not prevent you, but I wouldn't recommend for beginners. There are some cheat sheets available, as well as a really, really good talk if you want to learn more about it. Ubuntu is also using Snap, and Snap requires AppArmor and doesn't integrate, if I recall correctly, in any way in SELinux. So yeah, on Ubuntu systems you're forced to already use AppArmor, and turns out AppArmor is, as well as the SELinux system, a system which integrates into the Linux security module, so only one system can be activated at a time. So if you're on Ubuntu or derivatives of it, you cannot experiment or tinker with other systems. So, yeah, AppArmor. It is installed by default on Debian. You can already see it in systemd being active. It integrates more or less nicely into Flatpak, and you have in AppArmor to write a profile for each application you want. Interestingly, it also decides to just deny everything, and as I've mentioned before, it is also respecting the classic permission system. You can find a really good tutorial there. Sorry for the really, really long link. Hopefully somebody can take a photo of it. And there are also a lot of utilities available. Like I just wanted to list them here because you will notice something really interesting. While on SELinux, we're activating enforcing or permissive mode just by using a command. Of course, we can also write it into the policy if you really want to modify those files and compile them. In AppArmor, we can directly use this utility to set a whole profile of an application to, for example, just to a complaint mode. So we see that there's a violation, the profile wasn't written directly, or it tried to access files it shouldn't, but we can modify this on the fly. Yeah, it's a convenience thing, but it's really nice that it's already shipping with AppArmor. With AA-exec, you can even test your profiles before actually enforcing them on applications. So once again, a nice convenience feature. AA-notify and AA-logprof allows you to see those violations which are not yet captured or allowed in your profile, and really translates them to a proper rule. For example, the access is actually granted to load libc, because otherwise the binary wouldn't work. Yeah. Okay, this is already the talk. I didn't expect to be done so quickly. If you have further questions, feel free to reach out to me or to check me out at the village. We can then have a little bit of talk there. All right.
Right. All right. Thanks a lot for the cool talk from me as well. If you want to, we have 1.5 minutes left for questions. So does anybody have a question? Just raise your hand. I'll come with the microphone towards you so people can hear you.
Let's see if you found any of the mistakes in the slides.
Well, I was wondering what determines who can run shown and change group, change ownership on a file?
Of course, everybody can execute it, but whether you can manipulate the permissions is up to the actually owning user. Like, if you remove all the right access to the other users, of course, they cannot change the permission or change the owner anymore. So, yeah.
We have one more question. I think that should work time-wise.
Is there any way to block all of the users on my machine from using 777 completely across the entire machine, so it just never works?
I'm not aware of that, but in theory you could. It is a syscall, so in theory you could write an AppArmor profile to block this syscall with this specific mask. And I think there's also this magic tool called eBPF, which is not only a firewall, but also a firewall for system calls. So you could try to write a rule there, but I've never attempted that.
I see one more question in the back. I'm afraid we won't have time for that anymore, but I presume you can ask Simon after the talk. So, yeah, thanks a lot, SimonMicro.